Hello and welcome everybody. Nice to have you here today. So before we dive into really the unit testing approaches that I'm going to explain, at first I want to start with a short question. So who of you writes unit tests? So that is pretty much expected, so almost everyone. Does any one of you write integration tests? Also a lot of people. Then there's component tests. There's a few less, and end-to-end tests. Yeah, of course. So we can luckily all agree on writing tests, so we consider that important. That is a good thing for the first thing. And so how do these types of tests differ from each other? So in what extent do they differentiate from each other, these tests? So anybody an idea? So what these in what extent these tests differ from each other is they just cover a different scope of the application. Yeah. So the unit test is the narrowest scope. Integration and component test, they make it a bit wider, and end-to-end test, of course, has the widest scope. So we could say, well, these are all in some way unit tests, but only with different scopes. So maybe we at first should clarify what is a unit. And yeah, I guess we can start with a definition here. So a unit could be a method, a class, or even a cohesive group of classes that together compose a feature. But yeah, you might notice the word could, so that is not really a super clear definition of what a unit is. Maybe we can say it with a quote. So this is a lot of text to read, so maybe let me summarize this for you. So what this quote says is, in object-oriented design, we often treat a single class as a unit. Whereas if we have a more functional approach or a procedural approach, maybe we choose to have like functions as units. But in the end, it's a situational thing. And so what does it mean, situational? So the team should decide what makes sense to be a unit. And maybe you sometimes start like with a unit being a class and then end up with a bunch of closely related classes that together compose a unit. Yeah? And also, however you define it doesn't really matter. Yeah? So what really matters is writing these tests. So anyone an idea who might have said this, from whom this quote is? So this one is from Martin Fowler. So I guess we all know him, but do we get any closer on like how to write unit tests or how to figure out if we're doing it right? I guess, yeah, we need some more clarification, and so I thought it's best to get a bit more hands-on and yeah, create an example that we can step through together here. So the example that I created is a simple calculator, and let us first dive a little bit into how this calculator works so that we can later understand how we can test it and yeah, what makes up a good unit test. So at first, the calculator has a very clear and well-defined public interface, and it looks like this. So pretty easy. We have a mathematical expression as an input to the calculator, and of course, and hopefully, we get a numeric value as the result of this expression. So now let's have a look at what this expression looks like. So such a mathematical expression. So for example, here the calculation 10 plus 20 minus 3 plus 4 is represented by the expression 3 you see here below. And the calculator works in the way that it evaluates all the expressions from bottom up. And so it will at first like evaluate this one, 10 plus 20. Next it will evaluate this one, 3 plus 4. And finally it will then evaluate with the result of the bottommost expressions, evaluate this minus expression. And then the result should be 23 because 10 plus 20 is 30, 3 plus 4 is 7. And if you do the math correctly, 30 minus 7 then should be 23. So what we have here is that an expression is just a tree of operations. And each of the nodes is one of the operations plus, minus, multiply, or divide, and the leaves of the tree, they are just the numeric values. And if you're familiar with interpreters, you can think of this calculator as a very simple abstract syntax tree interpreter for mathematical expressions. How does it look in code? That was very theoretical, but let us have a look at this short main function and how we can express this equation here in code. So at first we of course need to instantiate the calculator. This is no voodoo. Next we create expressions for the minuend and the subtrahend of the complete equation. So these are expressed as these plus operations here. And then we can finally create the calculation expression that is the input to our calculator. And this, as you can see, is a minus expression and gets the minuend and the subtrahend. And with this calculation expression, we can then call our calculator. And in the end, we can print out the result, and this should hopefully be 23 in this case. So now let's have a closer look at the implementation. I will give you a short overview here. So at first, we talked a lot about expression already before, and in our code we defined an expression interface, and this expression interface looks exactly like this. It is a sealed interface, so we only allow for specific implementations of this interface, and you can see the implementations here. So we have a plus, minus, multiply, divide, and a value, and we will talk about the value expression later. So now that we have an expression, we probably need something that knows how to deal with these expressions. And for this, we created the expression handler interface. So the interface looks like this, and is again a sealed interface. So we only allow for specific implementations, and as you can see, for every expression there is a corresponding handler here that we provide. And this interface also defines this evaluate method that is then responsible for evaluating the concrete expression later on. And we will see in a minute how this is implemented with an example. And this example is the divide expression. So at first, let us look at the expression and then at the expression handler. So the divide expression we have here is just a simple record. And the record has two parameters, the dividend and the divisor. And these are themselves also expressions, but you might have noticed that these are not concrete expressions, but simply the expression interface. So they could be any expressions that are available. And of course, the divide record implements the expression interface. And the divide handler expression handler then looks like this. So we extend the or we implement the expression handler interface, and it is strictly typed to the divide expression. So this expression handler will not work with any other expression. And then we for sure implement the evaluate contract here of the expression handler interface. And as you can see, we have the calculator as an input, and of course the expression we want to evaluate. So why do we have the calculator here itself as an input to this expression handler? We come to this in a second. As you have seen above, the divisor and dividend of the divide expression, they are themselves not concrete expressions, but so we don't know what concrete type they have. And so we don't want to, like in every handler, distinguish all these different expressions and to figure out what expression handler, sorry, to use. So we just utilize the calculator to give us the result of these nested expressions. Yeah? So here you see that we get the value for the numeric value finally for the divisor, and then we do a little null check here or zero check to just throw a meaningful exception in case of a division by 0. And at the end we just again utilize the calculator to also give us the numeric value for the dividend expression. Yeah? And in the end we can just perform our division and we're done. So all the other expressions and expression handler look basically the same. So we will not go through them in detail here. But so that you get a grasp on it, how it is implemented. And next is, how do we express numbers? So we saw the value expression before at the interface. Yeah, so there's a value expression obviously, and the value expression looks like this. So the value expression just simply holds a numeric value, and the respective expression handler then simply returns this value. So this is, so to speak, a constant expression, and all the leaves of the tree, of the arithmetic tree, they should be of the type value. Yeah. So let us put it all together, what we saw before. So at some place we need to call all these methods and classes. And this is done in the calculator class. So you saw the calculator is input before. And here is all the magic done. And as you can see, it's not a lot of magic. We have here just a helper class, the expression handler provider. I will not go into detail about this here. This is just to move away some boilerplate code to get to know what handler we need for which expression. So we utilize this here to just get the respective handler for the input expression, and then just call evaluate and hand over the current calculator instance and the calculation expression. So that's it. Not a lot of magic here, though. So how do we test our calculator now? As I said before, so we have, or as you may have seen in the title, we have two ways of testing this. One I call the fine-grained style, so it has a more narrow scope, and one I call the coarse-grained style, and it has a wider scope for a unit. And yeah, we will see the differences between these two styles in a minute. So with the fine-grained style, we focus on single classes for testing. And this means that we test all components and all classes for our feature separately. This also includes that we need to test the component interaction somehow, so to know that when we put it all together, all the gears work together correctly. In this style, we also use test doubles, so mock objects or fake objects, for collaborators at a class level. So everything that is external to the functionality of a class will be mocked away. And in the end, this style has some parallels to the Mockist or London school of test-driven development, and also to the definition of solitary unit tests by Martin Fowler. The coarse-grained style, in contrast, tests or sees a cluster of cohesive object or classes as the unit. And the unit is then only tested via its public interface. Yeah, so we saw the public interface before. This is the method of the calculator. But we will see that in detail later. And when we create test doubles or fake objects, we only do this for external collaborators. So maybe database connections or other services we need to call within our feature. But all internal components, they will never be replaced by test doubles. And this style then has parallels to the classic or Detroit school of test-driven development, or yeah.
I would actually call that a small integration test already. What is an integration test? 5 classes together is still a unit test.
Yeah, that is a good question. So as I said before, to some extent, all of these different tests, you can say they're all unit tests, but with different scopes. And so I definitely recommend reading Martin Fowler's definition of the sociable unit tests, and that will make it more clear. But yeah, I definitely had this friction in my mind as well. So when we have like a couple of classes and components that we test together, isn't this already an integration test? Yeah. So yeah, you could definitely argue about that, but it's just about names. So right. So these are the two styles that we want to take a deeper look into, and we will start with the fine-grained style. So for the fine-grained style, what components should we test of our calculator? So I guess we can all agree on that we do not need to test the interfaces. As we saw before, there are no default methods implemented in there, so no business logic. I guess we can skip testing those. And maybe we also agree on not testing these records, because as we saw, also here we only have parameters, no business logic in there, so it's not worth writing tests for these. Yeah. So what is left are those classes. And as we are in the fine-grained style, we will create a class, a test for each and every class that we have here, except this one. So there is also a test in the demo code. You will get the link at the end. Yeah, but I will not go into detail here for this presentation because it doesn't really matter for the functionality of the calculator. And yeah, I think we will get the message anyway when we look at the other classes. So let us start here with the handler tests, and for this example I will only show you one test because all the other tests, they are basically the same, and this is the plus handler test in this case. So before we go through the test, we'll have a quick look at the plus expression here, and it looks basically like the divide expression. It also has two expressions as parameters, the origin and the addend expression, and again, no concrete type of expression, so we don't really know what expressions will be there. And next we will have the plus handler expression interface. Yeah, so there's obviously a plus handler, and the interface is different only in the way that we do not have a divide expression here as an input, but a plus expression. And what we now want to test is exactly this method, this evaluate method. Yeah, so let's look at the test of this method. This is some more code, but don't be afraid. We will go through it step by step, so it will be you will get it in a minute. So at first, we just create our plus handler, because that is the thing we want to test. So we create a concrete instance of it. And we also have our calculator here, but we do not create an instance here right away. But before each step, so before every class, we provide a mock object for the calculator. And this is exactly what I told you before. So we don't want to, in this case, care about how the calculator works internally or how do we need to like use it. We just create a mock for it because we solely concentrate on the functionality of the plus handler. And yeah, this is the test case here for the plus handler. So I utilize the parameterized test here. And what we have as an input for this test is the urgent value, the addend value, and also the expected result. So what you might notice is that we have no expressions here. This is because for the test, the expressions do not really matter. We will see that in a minute. And as you can see, we have a CSV source here for the test. So the first test case for this test would be urgent is 2, addend is 3, and the expected result is 5. And if you do the math, you will probably come to the same result. So yeah, let's dive a little into the test. So what we do first in the test. So at first, we create mock objects here for the urgent and addend expressions. Why do we do this? We do this because we do not really, first of all, we do not know what kind of expressions we get. And for the functionality of the plus handler, we also do not really care. So it can be any expression. And what we then do with these expressions is we define the behavior of the calculator according to these expressions. So we say when the calculator is called with an urgent expression, just return the urgent value. And if the calculator is called with the addend expression, just return the addend value. And then we can finally just instantiate the plus expression with the formally created mock objects and call our plus handler. And in the end, the result should be at least close to the expected result with a minimum offset here. So that's basically it. That's all there is to test for the plus handler. And as I said before, all the other tests basically work the same. So mocking the nested expressions, defining the behavior for the calculator, and then really calling the evaluate on the testee, on the test subject. For the dividend handler, there's also a test for the division by 0. So you can look that up in the demo code. It will be definitely there, I promise. So yeah, let's go on. Now let's have a look at the calculator. So the calculator itself has also an external or also a dependency, and this is the expression handler provider, but we won't really go deeply into it. It's just necessary like to understand what the collaborators of the calculator are. So now let's have a look at the thing we want to test. So for the calculator, there's only this public method, and this is what we want to test. And the test then looks like this. So what do we have here? At first, we have here again a calculator and the expression handler provider. So we need the expression handler provider because it's a collaborator for the calculator. But we do not do any instantiation here because we will do this here in the setup phase. Because here we at first create a mock object for the expression handler provider. Because again, we do not really want to test how this one works. But we only want to define, for our test, we only want to define the behavior of the expression handler provider so that we can test the inherent logic of the calculator. And secondly, we create a calculator instance with the respective expression handler provider. So the test then is relatively simple. At first, we define our expected result. And next, we create more mock objects. So this is one thing you realize here. So we'll create a lot of mock objects here for in the fine-grained style. We will create a mock object for the expression handler and for the input expression, because here we all again do not really know what kind of expression gets into, and we in fact do not really care for the functionality of the calculator. And then we define again the behavior of our collaborators, and so if the expression handler provider should give an expression handler for the given expression, we just say return the expression handler we defined before. And if we then call evaluate on that expression handler with our calculator instance and the input expression, then return the expected result. And yeah, finally we call the calculate method of the calculator and assert that the result is equal to the expected result. So what you may notice here is that we do not really test some business logic here. What we do test here is component interaction. Yeah? Just like one of the things I mentioned before when I described what things to consider in the fine-grained style. So let us draw a short conclusion. So what is good about this method? At first, you focus really on the exact behavior of the class under test. So no distractions from anything else, like, wow, how does other maybe in this case other expressions work, how does the expression handler or the expression handler provider work, or the calculator. If you test the expression handler, a specific one, you just focus simply on this. And this can help you to find the right level of abstraction and class design, because if you realize when you test that you have like really a lot of mock objects and a lot of input parameters and it gets really complicated, then maybe you need to overthink your class design. It also helps you to keep your test code small and straightforward. We saw this in the examples, so it's really short snippets of test code and really easy to understand. And easy to understand is also then easy to change and easy to write. And it also helps you to understand like the interaction of collaborators on a class level. As we saw before in the calculator test, through the definitions and through the assertions, we can deeply understand how these all these collaborators work together. So, but there are obviously also some negative things about this. And one of this is you may be forced or tempted to open up your API, because what we saw is we created mock objects for our expression and expression handlers, and but they were sealed classes, so Mockito cannot do it. So we need to unseal them to be able to mock them, and that may be not what you want. And also you may be tempted to add some test-only code. I see that very often, I must say, and this is not a really good thing because it poisons up your production code. And the tests and the implementations are tightly coupled, and this is also not a really good thing, because when you change something in the implementation, then you're most likely need to change also the test. This may be not a big penalty because the tests are really small, but definitely may need to do it. And the last of which is you have a lot of test classes, because for every class that contains business logic, you need another test class. So it might get a bit chaotic. So let's go to the coarse-grained style now, and this will be a little bit faster, I promise. So we'll be through in a minute. No worries. So what components should we test here then? Just a quick reminder. So we said for the coarse-grained style, we test our feature only through its public interface, and the public interface of the calculator only is here in the calculator. So for the coarse-grained style, in this case, we only need a test for the calculator. And yeah, let's dive into it and have a look at it. So at first, we create our calculator instance. And what you see here is that we also create a concrete instance of the expression handler provider. We have no mock objects here, so we really just use the concrete implementations of everything. yeah, because the calculator has no other external dependencies. If there was maybe a database connection or something else, of course we would use like test containers or test doubles or mock objects or something else. So now let's look into the test. The test again is a parameterized test. I really love these in JUnit 5, just to say. As we see here, the input here is an expression and the expected result. So let us look at how the test cases are defined then. Sorry, wrong direction. But as we see here, the definition of the test input is a bit more complex. Because if we test through the public interface, we maybe need to consider like all different expressions here, like plus, minus, divide, multiply, and maybe sometimes also different combinations, whatever you can think of. But the test itself then is relatively easy for at least for this calculator though. So we just put in the expression to the calculate method, and then see that the result is close to the expected result. And of course, there's also a division by zero test. Yeah. So this same test you can find on the fine-grained style as well for the divide handler test. Yeah. So that's all we need to do here. So we can already draw a conclusion on this one. So how can this style help us? It definitely helps us to find a clear and well-defined public interface. Because when you start to implement and test, and you see that you need a lot of marking, have a lot of complex input, then maybe your public interface is not really well defined, and the functionality of your feature is maybe too big, and you should split up. It helps you with information hiding, because in this case, we do not use test doubles for internal components. We only use them for external components. So in this style, we can keep our interfaces sealed and everything final and private, and nobody will care. This is what it makes easier to refactor the internals if the business logic doesn't change, because you can just change everything internally, and if the business logic stays the same, then the tests are all green, and you don't need to touch the test then. So, but what may be the negative things here to consider? Well, maybe you suffer quality of the internal design of a module, because as I said, you can just do whatever you want behind the public API. Yeah, so for the calculator, we could throw away all of the handlers and stuff. We could just implement it in one method. Yeah, and would be probably a really big method. Yeah, and really messy and hard to maintain, but yeah, we can do it, and the test will not lead us into any direction here, because they will still be green. And the test cases and mocking can get complex. I mean, we saw it in the calculator test here for the coarse-grained style before, so we have a really big block of different test cases to consider. Yeah, and of course you can split them up into separate tests, but then these tests all look like really the same, like copy code. Yeah? So this can really make things hard to understand and hard to implement. So, well, does it bring us any further in what test should we write? Well, the answer is, as always in software development, it depends. Yeah. So I'm really sorry that I cannot give you a definite solution here. So, but if you maybe know how to tackle a specific problem and your public interface is quite clear and you know it really well, then maybe for you the coarse-grained style is the right style. Yeah, you can do it right away. But maybe if you try to find the components for your feature, like the internal design of the classes and how they should fit together, and also trying to understand a certain algorithm, then it maybe makes sense to use the fine-grained style. And also one thing to consider here is which tests to write and which tests to keep in the end. So if you like implement a feature, maybe you want to have a lot of tests for small components, to make sure if you start this component or that class, that these work well as you like it. And when your implementation is done and you're pretty sure, then you maybe just keep these tests that only test like the whole feature through the public interface. And in the end, there are really many things to consider, and maybe it's a combination of both of these approaches may be a good idea and may lead to a reliable testing strategy. Or as Martin Fowler says it, it's really a situational thing, and the team should decide. But I hope I could give you some like insights on what consequences are there for specific testing strategies, and you can now better decide on what makes sense for you. And one thing at the end, some credits to my colleague or a friend of mine, former colleague at Open Value. So with him together, I had a lot of discussions on how to do tests, and he helped me to create the example and application. So a lot of thanks to him. And yeah, this is it for today from me. And thank you for you all being here, and I hope it was fun, but because for me it was for sure. Thank you. So, any questions? Or are you all hungry? Okay, here. Yeah. For this case, we in the implementation for the fine-grained style, we just unsealed the interface, and this is like a consideration. You need to be really clear about it because it opens up your API. You may not want to do it. It may be doable. That is on you. You can also like use concrete expressions in the test. Don't use mock objects. But then maybe you need some explanations, because if there's only like plus expressions, one could ask, why only test plus expressions? You should test divide and minus and all the things too. Yeah, and then it needs some explanation. So yeah, it's you can consider this, but you really need to keep in mind, if you open up your API, this can like be not a good thing for your feature. It simply depends where you want to use it, at who you want to use it. So you need to know your audience if you can do it. Yeah.
What kind of tests do you write more often?
I myself like the fine-grained style more, so I do write these class tests more often. So this is more my kind of style of testing, but I also use the other approach at some occasions. So this is not a clear, left or right thing. So, yeah. Thank you. I will be at the stand of Open Value, right next to Azul and Gradle. So please come by and we can have a talk.
Can I ask something? You haven't tested the really interesting edge cases. For example, if one of the values evaluates to infinity or something like that.
Yeah.
So you haven't considered expanding in the sense that you use more different number examples, so your CSV lists get the more interesting stuff.
Yeah, that's true, and we did it on purpose here to make it more easy for the presentation. But of course, there should be more edge cases to be considered to make it real robust against failure. Yeah, that's totally true. But we did it here on purpose to keep it a bit more simple. Thank you. So then, everybody grab lunch and have fun.